All right, let's put on our hard hats today. We're going to become master builders of software. We're not just laying bricks. We're going to explore the actual blueprints for creating modern, adaptable systems, the kind that can evolve right along with our needs. Okay, let's dive in.
You know, this is the fundamental question, isn't it? It's what every builder, every developer, every architect has to wrestle with. You build something magnificent, but the second a new feature request comes in, the whole structure just groans under the pressure. Well, today, we're going to answer that question by looking at the shift from one giant, rigid structure to a team of flexible, collaborating specialists.
So, to really appreciate the solution, we have to get our heads around the problem first. And for decades, the standard way to build software was what's called a monolithic architecture. The best way to think of it, imagine trying to construct an entire skyscraper from a single, massive block of concrete. Let's make this real. Picture an online bookstore. In the old monolithic world, every single piece of that store, the book catalog, the shopping cart, how orders are processed, customer data, it's all fused together inside one giant digital box. It's all one interconnected, totally interdependent program. Now, on day one, that might seem simple enough, but you start to see the cracks pretty darn quick.
And here's where the real frustration kicks in. With monoliths, everything is so tightly integrated. You make one tiny change over here, and suddenly you've created this huge, unforeseen problem somewhere else. It's a ripple effect. Want to update just the shipping system? Sorry, you have to redeploy the entire application. It's risky, it's slow, it's expensive, and it makes it incredibly difficult for the software to adapt to anything.
So all that frustration with monoliths, it led to a whole new philosophy, a new architectural blueprint designed from the ground up for flexibility. And this is what we call service-oriented architecture, or SOA. It's not a specific technology. You can't go download it. It's a way of thinking about how to build systems that can actually adapt and grow. The key phrases here are assembly and loosely coupled services. Instead of one single rigid structure, we're now thinking about building with independent components, like high-tech Lego bricks, that we can combine and reconfigure whenever we need to. Let's see how this actually works. Okay, let's build an SOA system right here, from the ground up. Every structure needs a foundation, right? Well, in our case, this is the IT systems layer. It's the physical hardware, the servers, and yeah, often those old legacy systems that the business just can't get rid of. This is our bedrock. Now, to deal with those old legacy systems, we use something called wrapper services. These guys act as translators. They literally wrap the old technology in a modern interface so it can talk to the rest of our new, shiny system.
Now we get to the real core building blocks. These are the atomic services. And just like the name suggests, they are specialists. Each one is designed to do one basic thing, and do it exceptionally well. Think of services like check inventory, get customer details, or validate a credit card. These are our fundamental single-purpose tools.
Okay, so we've got our specialists in place. Now we need a manager to coordinate them, right? That's the job of Composite services. These services don't do the basic work themselves. Instead, they orchestrate the atomic services to complete a bigger business process. For example, a place order service would coordinate the inventory, customer, and payment services to get the job done.
And finally, at the very top of our structure, we have the user interfaces. This is how people actually interact with our beautifully architected system. It's the websites and the mobile apps. And right there, you can see the complete blueprint, from the foundational hardware all the way up to the end user.
So SOA gives us the master plan, right? It's the blueprint. But how do we actually manufacture the bricks? Well, a very, very popular and powerful way to implement this blueprint today is by using what are called microservices. These are the modern, high-performance building blocks for our architecture.
So this is a really crucial point to understand. SOA is the overall blueprint. It's the what and the why. Microservices are a specific implementation. It's the how. While SOA thinks about organizing services into these neat layers, microservices really double down on the idea of complete and total independence for each small unit.
And now for the magic. This is where the true power of this whole approach just becomes crystal clear. Let's put our new bookstore architecture to the test with a real-world scenario. It's the biggest shopping day of the year. What happens? Suddenly, the shopping cart service is under immense pressure. 10 times the normal amount of traffic is hitting it all at once. In the old monolithic world, the entire application would slow to a crawl or even crash. The catalog, the order system, everything would suffer. But not here.
And this, right here, this is the payoff.
Because our services are independent, we can scale only the part of the system that needs it. We can just spin up more copies of the cart service to handle the load. And the book catalog and order services, they're completely unaffected. They don't even know anything is happening. This is independent scaling, and it is an absolute game changer for building resilient systems.
So we've been talking about these services as specialists, and just like on any team, different players have different roles. To build a truly effective system, we need to understand the distinct jobs our services can play within the architecture.
First up is the atomic service. This is the Doer. It's the foundational building block that performs a core function all by itself. Think of it like a simple, reliable hammer in your toolbox. A customer service that handles creating, reading, and updating customer info is a perfect example of an atomic service.
The wrapper service acts as a translator. Its whole job is to make those older legacy systems compatible with our new architecture. It's kind of like an adapter that lets your old vintage stereo connect to a brand new set of speakers.
And finally, there's the Composite service. This is the manager, the orchestrator. Think of it as the project manager who coordinates a whole team of specialists to complete a complex job. That place order service is a classic Composite service. It doesn't handle carts or shipping itself. It tells the cart service, the customer service, and the shipping service what to do and in what order.
Okay, we've covered a lot of ground here, from the problems of the monolith to the layered blueprint of SOA and the raw power of microservices. So let's just slow down for a minute and recap the essential concepts you can take with you as you start to architect your own future systems.
There are 3 core ideas to really lock in. First, the great unbundling. That strategic shift from one big clunky box to a flexible team of specialists. Second, the universal translator. The magic of having standard interfaces that allow any service to talk to any other, no matter how it was built. And third, the power of micro. The radical independence that microservices give us to deploy and, most importantly, scale parts of our system without affecting the whole thing.
And it all comes down to this. This isn't just some technical exercise we do for fun. The entire purpose of this architectural approach, the reason we do all this, is to build systems that don't break when they need to change. It's about creating software that is adaptable, resilient, and scalable enough to evolve right alongside the business it serves.
So, we've walked through the problem, we've laid out the blueprint, and we've examined the modern building blocks. You now have the core principles of a master builder. The only question left is the one you see right here. You have the blueprint. What will you build?